Ever wondered what happens when a star dies? Does it vanish or transform into something extraordinary? As we journey through the cosmos, we encounter many mysteries, one of which is the life cycle of a star. Picture a star, its radiant light illuminating the universe, its energy radiating across galaxies. But what happens when that light fades? When the star has expended all its fuel? In the grand scheme of celestial events, stars don't merely disappear. Instead, they undergo a spectacular transformation, an explosion of energy and matter that shakes the very fabric of space. This dramatic end, a supernova, is only the beginning of another story, a story of unimaginable density, gravity, and magnetic fields. This is the story of the birth of a neutron star, an object so dense a teaspoonful of its matter would weigh as much as a mountain. In the vast cosmic theater, the death of a star gives birth to an enigma, the neutron star. Imagine a celestial body so dense that a teaspoonful of its matter would weigh more than Mount Everest. Welcome to the world of neutron stars. Our journey begins with a star, not unlike our sun, but much more massive. Over millions of years, this star burns through its nuclear fuel, transforming hydrogen into helium, then helium into carbon, and so on, until it creates a core of iron. Iron, however, doesn't like to play the fusion game, and so the star's energy production comes to a sudden halt. With no energy to counteract the force of gravity, the iron core begins to collapse under its own weight, shrinking down to a size unimaginably small. This collapse happens so quickly, in less than a second, that it sends a shockwave, rippling through the outer layers of the star. This shockwave is so powerful that it literally blows the star apart in a cataclysmic explosion known as a supernova. But what of the core? The story isn't over yet. As the core collapses, protons and electrons are squeezed together, forming neutrons and neutrinos. The neutrinos escape, but the neutrons are packed so closely together that they form a dense ball, just about 20 kilometers in diameter. This is the birth of a neutron star. In this tiny space, matter is so densely packed that a single sugar cube-sized piece of a neutron star would weigh as much as a mountain. The force of gravity is so strong that a pea dropped from a height of 1 meter would hit the surface of a neutron star at about half the speed of light. But despite their incredible density and gravitational force, neutron stars are not black holes. Their gravity is strong but not strong enough to trap light, so we can observe them, learn from them, and marvel at the extreme conditions they represent. So the death of a star is not an end, but a spectacular beginning of a new entity, the neutron star. Neutron stars, though tiny in comparison to other celestial bodies, pack quite a punch. Let's dive a bit deeper and explore these peculiar objects. Neutron stars are extreme in every sense of the word. They're incredibly dense, so much so that a single sugar cube-sized piece of neutron star would weigh about as much as Mount Everest. Now that's a heavy sugar cube, isn't it? These stars are not only dense, but they also have a super strong gravitational pull. In fact, the gravity on a neutron star is about 2 billion times stronger than the gravity we experience here on Earth. Imagine trying to lift a feather on a neutron star. It would feel as heavy as an elephant. But there's more. Neutron stars are also home to the strongest magnetic fields in the universe. These magnetic fields are 1 trillion times stronger than our Earth's. These intense magnetic fields whip up powerful winds of particles, creating jets that shoot out into space at nearly the speed of light. And how about their rotation? Neutron stars spin incredibly fast, faster than a kitchen blender. Some neutron stars, known as pulsars, can spin hundreds of times per second. As they spin, they emit beams of radiation that sweep across the cosmos like a lighthouse beacon. When this beam points towards Earth, we can detect it as a pulse of light or radio waves. Neutron stars also play a crucial role as the universe's fastest spinning objects. This extreme rotation, coupled with their intense magnetic field, allows them to generate beams of electromagnetic radiation. These beams can be detected by telescopes, allowing us to study these fascinating celestial bodies from our home planet. So, despite being only about 20 kilometers in diameter, these stars are far from ordinary. They are some of the most extreme and fascinating objects in the universe. Despite their small size, neutron stars are powerhouses, exhibiting some of the most extreme conditions in the universe. Neutron stars are not just fascinating objects, they play a crucial part in the cosmic drama. As the remnants of massive stars, neutron stars forge elements heavier than iron in their explosive birth. This process, known as R-process nucleosynthesis, seeds the cosmos with gold, platinum, and other precious elements. When neutron stars collide, they spew these materials into space, sprinkling the universe with the building blocks of planets and life. But the influence of neutron stars doesn't end there. Their intense gravity and magnetic fields make them perfect laboratories for studying extreme physics. The information we glean from these celestial laboratories could potentially unlock new understandings about the fundamental laws of nature. Some even speculate that the harsh conditions on the surface of neutron stars could harbor extremophile life forms. While this idea remains purely speculative, it underlines the wide-ranging potential of these cosmic objects. Neutron stars, thus, hold the key to several unanswered questions about the universe. Neutron stars, the cosmic enigma born from a star's death, are truly fascinating. Their story begins with the explosive demise of a massive star, an event of such magnitude that it births an entity of extraordinary density and gravity. These celestial bodies with their unique properties are as awe-inspiring as they are perplexing. The neutron star, despite its small size, is incredibly dense, with a teaspoon of its matter weighing as much as a mountain. Its magnetic field is 1,000,000 times stronger than the Earth's, and it spins at dizzying speeds, emitting beams of radiation that sweep across the cosmos like a cosmic lighthouse. In the grand scheme of the universe, neutron stars play a significant role. They provide us with valuable insights into the laws of physics under extreme conditions, and their collisions result in spectacular cosmic fireworks, creating elements heavier than iron. As we delve deeper into the cosmos, neutron stars continue to challenge and inspire, a testament to the endless wonders of our universe. Stay with us to increase your knowledge and subscribe for more videos.